So, in organic, the next topic is, technically the second last topic is basically halogens. In this topic, the initial part of the chapter is exactly the same as it was in O level, the general physical properties, like the color states of halogen. And then we move towards the reactivity of halogen. You know that the halogen become more reactive going down the, less reactive going down the group. And then we have a very important reaction of halogen with hydrogen gas and the stability of halide. And then we move towards the reducing power of halidine and disproportionation reaction. So the last few reactions, like 2-3 reactions of halogen, are basically the typical A-level stuff. The initial part, which I'm going to cover in this video, is basically a very basic O-levels type reaction. Okay, so let's start with the basic general introduction. So yes, halogens are basically group 17, and they are the typical non-metals. Okay, so all halogens are non-metals. Yes, we all know that group 17 or group 7 is basically a non-metal. And we have fluorine, F2, Cl2, Br2, and I2. Obviously, इसके नीचे acetine होता है, which is very less reactive, so we are not going to cover it up. So you have fluorine, chlorine are gases, bromine is liquid, and iodine is basically a solid in nature. Okay, so iodine is solid. Yes, we have acetine, which is solid as well. And the color of fluorine is basically a pale yellow gas. Okay, so it is a pale yellow gas. Okay, in a similar way, chlorine is also yellow, but it's give a greenish type shade, so greenish yellow. So fluorine and chlorine are the yellow gas. Okay, bromine is basically reddish brown liquid. In terms of iodine, so iodine is basically in a solid form. It's a gray, or you can say it's a black solid. But keep in mind that it gives a purple color in a vapor form. Purple vapor. Okay, so whenever you have an iodine in a vapor form, it's a purple vapor. In a similar way, acetine is basically also a black solid. Okay, so you can see going down the group, the physical state changes from gas to liquid to solid, technically, and then you can see the color intensity of the color also increases from pale yellow going to reddish brown to gray black solid. So it means that basically why the color changes and why the physical state changes all depends on the intermolecular forces. So going down the group, as you can see, all these fluorine are the diatomic molecule. They are the typical non-metal diatomic molecules. Typical non-metal diatomic molecule. They all are non-polar. And the physical state and especially the color as well depends on the extent of intermolecular forces in all non-polar gases. So fluorine से iodine तक, when you're going down the group, as the MR increases, the number of electrons increases, and due to increase in the MR and the number of electron, the extent of dispersion forces, जिसको van der Waals forces भी कहते हैं, वो increase हो जाता है, जिसकी वजह से इनकी physical state और color change हो जाता है. ठीक है? So going down the group, as the MR increases, the number of electrons increases, the extent of van der Waals forces increases. Molecule come close to each other, so gas से liquid, और आयोडीन के केस में और स्ट्रॉन्गर होती है तो लिक्विड से सॉलिड फॉर्म में कन्वर्जन हो जाता है. ठीक है, सो इफ दे आस्क यू व्हाई द फिजिकल स्टेट, और they can ask in terms of the boiling point as well, why the boiling point of halogen increases down the group. So आप रीजन हमेशा सेम रखेंगे. ठीक है, सो द फिजिकल स्टेट चेंज होती है, इसका रीजन बॉइलिंग पॉइंट इंक्रीज होता है, इसका रीजन, और इंटेंसिटी ऑफ कलर भी इंक्रीज हो जाती है. इंटेंसिटी ऑफ कलर इंक्रीजेस. ठीक है, डाउन द ग्रुप. इन सारी बातों का एक ही रीजन है, विच आई एम गोइंग टू राइट इट डाउन इन अ व्हाइल, ठीक है। सो इन सब का रीजन एक ही है। तो रीजन क्या होगा, आप लिखेंगे गोइंग डाउन ग्रुप 7, Group 17, as the MR increases, number of electrons increases, due to which the extent of dispersion forces, ये वही वैन वॉल फोर्सेस हैं, increases and boiling point increases. ठीक है बेटा, so going down the group, as the MR increases, the number of electrons increases, at which their boiling point increases. I hope the point is clear. हम बहुत पहले से जो है वो सारी चीजें in terms of bonding intermolecular forces में पढ़कर आए हुए, ठीक है। So this is the reason behind their different physical state, gas to liquid to solid, their different color and their difference in boiling point. Let's move towards the next part, which is the reactivity of halogens. Reactivity of halogens. Okay. Now, as you know that the halogens are typical non-metals, and all halogens, when they react, they always get the negative charge. Okay. So let's talk about if we have fluorine. Whenever fluorine react, it always forming F negative ion. Okay, ऐसा ही है ना? They are called halide, and they can X negative, F negative ion by gaining an electron. So can I say that this process is called reduction? All fluorine, or sorry, all halogens are getting reduced by themselves. So can I say that all halogens are basically the oxidizing agent? All halogens are oxidizing agent. ठीक है? Clear? They gain an electron, they itself get reduced. Okay? So they are basically the oxidizing agent. You can say the gain of an electron depends on the electronegativity value. Okay? So if you have any non-metal that react by gaining an electron and have a higher electronegativity value, then it's going to be more reactive. ठीक है? कोई भी halogen, कोई भी non-metal, इनफैक्ट चाहे वो ऑक्सीजन हो चाहे नाइट्रोजन हो, जब भी वो रिएक्ट करता है, all non-metals always make a negative ion by gaining an electron. So whenever and it depends on the value of the electronegativity. ठीक है? So can I say that the reactivity of non-metals all non-metals, ठीक है, depends on electronegativity value. सही है? So the reactivity depends on the electronegativity value. Larger the electronegativity value, more higher would be the reactivity. ठीक है? So reactivity directly depend करती है electronegativity पे. So yes, if we talk about the electronegativity, which is generally represented by En. Electronegativity को हम En से represent करते हैं. तो can I say that this is a trend of electronegativity? If you go down the group from top to bottom in any group of the periodic table, the En decreases due to increase in atomic radius and shielding effect. ठीक है? Going down the group, the electronegativity value decrease. The electronegativity has the same trend as the trend of ionization energy. Electronegativity और ionization energy का trend exactly same होता है. ठीक है? तो keeping this one in mind, if we list down the halogens like fluorine, chlorine, bromine, and iodine, can I say that going down the group, the reactivity decreases? Reactivity decreases due to decrease in the electronegativity value. Okay, the power to gain an electron decreases. So can I say that fluorine is going to be the most reactive? And most और strongest, most powerful की जगह हम term use कर रहे हैं strongest oxidizing agent. ठीक है बेटा? In a similar way, iodine is going to be the least reactive. ठीक है? And this is going to be the weakest oxidizing agent. Clear? So it should be very clear about the reactivity of halogen. ठीक है? The reactivity of halogen decreases down the group. ठीक है? और इसके decrease होने का reason the decrease in the electronegativity value है. Clear? So ये सारी चीजें आपके ध्यान में होनी चाहिए. Whenever you have to discuss about the reactivity, make sure that, और वैसे भी हमें याद रहेगा, we already knew that basically fluorine is the most reactive element among halogen. हमने O levels में भी ये सीरीज जो है वो याद करी थी. ठीक है? Keeping this one in mind, let's move towards the displacement reaction of halogen. यानी अगर आपके पास कोई कंपाउंड है लेस रिएक्टिव हैलोजन का एंड यू ऐड मोर रिएक्टिव हैलोजन, इट कैन इजीली बी डिस्प्लेस. हम ओ लेवल से पढ़ते आ रहे हैं. सिमिलर रिएक्शन है, जैसे मेटल डिस्प्लेसमेंट में क्या होता है, मोर रिएक्टिव मेटल कैन डिस्प्लेस अ लेस रिएक्टिव मेटल. इसी तरह यहाँ स्टेटमेंट होगा, मोर रिएक्टिव हैलोजन कैन डिस्प्लेस less reactive halogen from the aqueous solution of its salt. ठीक है? From the aqueous solution of its salt. Keeping this one in mind, let's suppose if you have a solution of KBr aqueous, ठीक है? And if you add chlorine in an aqueous form or in a gas form, plunge in chlorine gas, it's the same thing. You can write aqueous as well. So it will form 2KCl aqueous, and you have to balance 2 here, plus Br2 liquid. And this displacement reaction takes place, and you will see because of the bromine, ठीक है, your solution become orange or brown solution. ठीक है? It could be a brown or orange, orangish brown solution. Clear? And this reaction is possible as chlorine is more reactive as compared to bromine. ठीक है? Chlorine is more reactive. And if I ask you to write down the ionic equation for this one, अगर हम इसे ionic equation form में represent करें, so you know that K positive is a spectator ion. K positive एक स्पेक्टेटर आइन है. सो हम के पॉजिटिव की को हटा के इसको Br नेगेटिव एक्वस लिख देते हैं. Adding Cl2, either it's a gas or in aqueous form, doesn't make any difference, making 2Cl negative aqueous plus Br2 liquid. ठीक है? Now इसी इक्वेशन को थोड़ा सा हम लिखते हैं in terms of oxidation and reduction. Clear? So you can see the chlorine is getting reduced. It's a reduction. Bromine is getting oxidized. Bromine getting oxidized. ठीक है? तो can I say that chlorine is a stronger oxidizing agent as bromine. That's why उसने bromine को oxidize कर दिया. I can write another statement as well. Br negative is a stronger. This is not bromine. This is bromide ion. ठीक है? Br negative is a stronger reducing agent as Cl negative. ठीक है? तो अगर आप हेलोजन की बात कर रहे हैं तो यस, क्लोरीन इज मोर रिएक्टिव. क्लोरीन इज अ स्ट्रॉन्गर ऑक्सीडाइजिंग एजेंट, इसलिए उसने ब्रोमीन Br नेगेटिव को ऑक्सीडाइज कर दिया. ठीक है? इज अ सिमिलर वे Br नेगेटिव इज अ स्ट्रॉन्गर रिड्यूसिंग एजेंट एज कंपेयर टू Cl नेगेटिव, इसलिए उसने Br नेगेटिव ने क्लोरीन को Cl नेगेटिव में रिड्यूस कर दिया. ठीक है? क्लियर? सो दैट्स अबाउट द ऑक्सीडाइजिंग एंड रिड्यूसिंग पावर. ठीक है? क्लियर? इन अ सिमिलर वे, इफ दे आस्क यू इन एग्जाम, you have a solution of KBr aqueous and you are adding iodine, aqueous iodine in this one. What should be the product? तो आप बोलेंगे no change or no reaction. ठीक है? No reaction. Why? Because iodine is less reactive than bromine, so it cannot displace bromine from its aqueous salt. ठीक है? So bromine iodine जो है वो bromine से less reactive है, इसलिए ये reaction possible नहीं होगा. ठीक है? आई होप के आप इस तरह के रिएक्शंस को हैंडल कर लेंगे. देयर आर फ्यू एमसीक्यूज व्हाइल वी डू पास पेपर, वी डू द एमसीक्यूज एज वेल. नाउ द रिएक्टिविटी ऑफ हैलोजन से रिलेटेड एक बहुत इंपॉर्टेंट रिएक्शन है व्हिच इज द रिएक्शन विद हैलोजेंस, सॉरी हाइड्रोजन. रिएक्शन with hydrogen. All halogens react with hydrogen forming hydrogen halide. तो इन सबके हाइड्रोजन गैस के साथ रिएक्शन हो जाए. ठीक है? तो हम इस रिएक्शन को का नाम फॉर्मेशन ऑफ हाइड्रोजन हैलाइड्स भी कर सकते हैं. ठीक है? फॉर्मेशन ऑफ हाइड्रोजन हैलाइड्स. Clear? So this is basically another name of this reaction. So if I generally write, if you have halogen reacting with hydrogen gas, halogen की physical state कुछ भी हो सकती है, चलें gas form में, forming hydrogen halide. ठीक है? So this is the general reaction. All halogen react with hydrogen forming their respective halide. Depending on the reactivity of halogen, the extent of reaction is different. जैसे fluorine F2 is the most reactive. So fluorine react with hydrogen even in a cool dark condition. Chlorine requires sunlight. ब्रोमीन और आयोडीन के लिए आपको हीट करना पड़ता है. ठीक है? तो जैसे जैसे हैलोजन की रिएक्टिविटी डाउन द ग्रुप डिक्रीज होती है, दे all react with hydrogen, but the conditions are going to be different. Okay, so if the first reaction is the reaction of hydrogen with fluorine, so if you have hydrogen gas reacting with F2 gas forming HF, okay, so which is also in a gas form. So you have HF hydrogen fluoride gas. Okay, clear? And this reaction takes place even in a cool dark condition. So it is an explosive reaction in cool dark conditions. ठीक है बेटा? So they react explosively even in a cool dark condition. Now the reactivity of chlorine is less than fluorine. So if the hydrogen gas reacting with Cl2 gas, now it will form hydrogen chloride gas. Okay? Now again the reaction is explosive, but in the presence of sunlight. Explosive reaction. Okay? In the presence of sunlight. Or UV light. I think UV light is the best term for sunlight. Okay? So this is explosive reaction, but required a sunlight for completion. Okay? Clear? In a similar way, if you have the same reaction taking place with bromine Br2, I'm taking Br2 in a gas form, right? And taking 2HBr, which is also gas. Okay. Now, this reaction is a slow reaction and it required heating. So, bromine is less reactive than chlorine. So, slow reaction, okay? And on heating, they react together. क्लियर बेटा सो यस ब्रोमीन को हीटिंग रिक्वायर्ड है अब आपको एक क्लियर हो गया होगा कि आयोडीन को भी हीटिंग रिक्वायर्ड है बट टू अ लार्जर एक्सटेंट ठीक है सो आयोडीन को हमें ब्रोमीन के कंपैरिजन में थोड़ा ज्यादा हाई टेम्परेचर पे हीट करना पड़ेगा ठीक है सो हाइड्रोजन प्लस आयोडीन इन अ गैस फॉर्म फॉर्मिंग 2 हाइड्रोजन आयोडाइड गैस ठीक है अब देखें इसमें भी आपके पास हीटिंग रिक्वायर्ड होती है लेकिन प्रॉब्लम यह है कि द अमाउंट ऑफ हीटिंग रिक्वायर्ड इज ग्रेटर एज कंपेयर टू ब्रोमीन ब्रोमीन के कंपैरिजन में ज्यादा हीटिंग रिक्वायर्ड होती है ठीक है उस ज्यादा हीटिंग की वजह से क्या होता है कि द हाइड्रोजन आयोडाइड HI स्टार्ट डीकंपोजिंग ठीक है वो डीकंपोज होना शुरू हो जाता है दैट्स व्हाई इट इज अ रिवर्सिबल इक्वेशन ठीक है ये बात याद रखिएगा कि आयोडीन के केस में यू ऑलवेज हैव अ रिवर्सिबल इक्वेशन एंड इक्विलिब्रियम के चैप्टर में इस इक्वेशन को कई जगह इस्तेमाल किया तो दैट्स व्हाई कैन आई से दैट इट फॉर्म एन इक्विलिब्रियम मिक्सचर ऑन हीटिंग ठीक है इट इज अ रिवर्सिबल रिएक्शन एंड इट फॉर्म अ इक्विलिब्रियम मिक्सचर ऑन हीटिंग क्लियर सो दैट्स हाउ यू आर गोइंग टू write it down. So yes, fluorine most reactive, cool dark condition में explosive reaction होगा. Chlorine less reactive है, it react in a UV light. Bromine even less reactive, it has slow reaction on heating. Iodine form an equilibrium mixture because the temperature required for the reaction is sufficient enough for the decomposition of the product. So as you heat it to make it react, the product start decomposing. Okay, so that's how this reaction is a reversible reaction. Now अब एक रेलेवेंट टॉपिक है यहीं कवर अप कर लेते हैं विच इज अबाउट द थर्मल स्टेबिलिटी ऑफ हाइड्रोजन हैलाइड ठीक है बिफोर आई डू दिस टॉपिक कीप इन माइंड हमने पढ़ा है कि इन कोवलेंट कंपाउंड एज द बॉन्ड लेंथ इंक्रीजेस द बॉन्ड एनर्जी डिक्रीजेस ठीक है जितना लार्जर बॉन्ड लेंथ होगी उतना बॉन्ड एनर्जी कम होगी उतना वीकर बॉन्ड फॉर्म होगा और बॉन्ड लेंथ डिपेंड करती है एटॉमिक रेडियस के ऊपर सो कैन आई से दैट गोइंग डाउन द ग्रुप एज द रेडियस ऑफ हैलोजन इंक्रीजेस हैलोजन का रेडियस इंक्रीज होता रहता है ड्यू टू द इंक्रीज इन द रेडियस ऑफ हैलोजन द बॉन्ड लेंथ इंक्रीजेस एंड द बॉन्ड एनर्जी डिक्रीजेस ठीक है सो गोइंग डाउन द ग्रुप दे बिकम थर्मली लेस स्टेबल सबसे वीकेस्ट बॉन्ड हाइड्रोजन और आयोडीन का होगा ठीक है और सबसे स्ट्रॉन्गेस्ट बॉन्ड हाइड्रोजन और फ्लोरीन का होगा इस बात को रिप्रेजेंट करने के लिए मैं बॉन्ड लेंथ को इस तरह से रिप्रेजेंट तो एच एफ स्मॉलर है एच सी एल लार्जर है एच बी आर इज इवन मोर लार्जर ठीक है और एच आई इज इवन मोर लार्जर ठीक है सो कैन आई से दैट गोइंग डाउन द ग्रुप गोइंग डाउन the group the bond length increases due to increase in atomic radius तो ये bond energy decreases and thermal stability decreases as well ठीक है means this one is the weakest bond ठीक है least stable this one is the strongest bond. Most stable. So can I say that going down the group, the thermal stability decreases due to increase in the bond length and decrease in the bond energy. That's basically the idea. Okay. So going down the group, as the bond length increases, the bond energy decreases, and the thermal stability also decreases. So hydrogen iodide thermally least stable hai as compared to the hydrogen bromide, and hydrogen bromide is less stable. Chloride के मुकाबले में सबसे strongest hydrogen fluoride है. ठीक है, clear? And then the last section of this like this simple topic before we move towards the other reaction of halide ion. Let's do the thing which we have done in our O levels and in our practical as well, which is the test for the presence of halides. Test for the presence of halide ion. Okay, test for the presence of halide ions. You remember, yes, we add Ag ammonical silver nitrate, or we add silver AgNO3. Chloride will give white precipitate, bromide cream precipitate, iodide yellow precipitate. ठीक है, तो ये वही reaction है यहाँ पर. If you remember, the reagent normally added is Ag positive. तो हम यहाँ थोड़ा सा और elaborate करके लिख लेते हैं. Basically, the reagent is a mixture of AgNO3 plus NH3. ठीक है, अमोनिया और AgNO3 का मिक्सचर होता है, एंड दिस इज कॉल्ड अमोनिकल सिल्वर नाइट्रेट. अमोनिकल सिल्वर nitrate. ठीक है, so ammonical silver nitrate is basically the reagent. We dissolve silver nitrate in ammonia. जैसे aqueous solution बनता है वैसे ही अमोनिया में dissolve करके solution बनाते हैं. In ammonical silver nitrate you have Ag positive and we used as aqueous plus. अगर आपके पास कोई भी halide ion होगा aqueous तो ये react करेंगे and they form the precipitate of silver halide. ठीक है, यहाँ पर आपके पास silver halide के precipitate form होंगे. Clear? And these precipitate have different color. Clear? Let's suppose if I take an example, if you are adding Ag positive aqueous plus Cl negative, अगर आपके पास chloride ion present होगा तो ये बनेगा AgCl solid. And these precipitate have white color. ठीक है, these are the white PPT. ब्रोमाइड के केस में AgBr का कलर क्या होगा? क्रीम होगा, और AgI का कलर होगा येलो. ठीक है, तो हम यहां पर ये बात लिख लेते हैं. AgCl solid is white, AgBr solid is cream, और AgI solid is yellow. हम इसके कलर लिख लेते हैं. These are the white PPT. These are the cream precipitate. And these are the yellow precipitate. थोड़ा सा yellowish color हो जाता है. Clear? So this is very important that you know the color of these precipitate, and you should know the identity that when you adding Ag positive in Br negative, cream precipitate जो बन रहे हैं उनका color क्या है. ठीक है, clear? Now इनकी कलर में समटाइम कंफ्यूजन हो जाता है. क्रीम एंड व्हाइट कलर लुक्स टुगेदर एक जैसे दिखते हैं, तो कंपैरेटिवली तो आप बता सकते हैं which one is cream and which one is white, but if you just have one precipitate, so you might sometime get it confused कि either this is white or this is cream. So उसके लिए याद रखिएगा कि इनकी solubility चेक की जाती है प्रेसिपिटेट की अमोनिया में. ठीक है, ये जो आपके पास प्रेसिपिटेट हैं उनकी solubility. So PPT, the solubility of precipitate in NH3. ठीक है, एक्वस अमोनिया इन प्रेसिपिटेट में डिसॉल्व किया जाता है तो उनकी प्रेसिपिटिटी जो है वो चेंज हो जाती है. क्लियर? और उसी बात को हम यहाँ लिख रहे हैं इस जगह पर, दिस गैप. सो इफ यू हैव अ क्लोराइड आयन which is Cl negative, it's a white PPT, soluble in dilute NH3+. ठीक है, तो they are soluble in a similar way bromide ion, which is Br negative. They are cream precipitate, and they are soluble. Sometimes we use the term partially soluble in concentrated NH3. They are insoluble in dilute. ठीक है? In a similar way, iodide ion, which is I negative, yellow PPT, insoluble in both dilute or concentrated NH3. ठीक है बेटा, so this is very important. If you know this table, I think आपको ये याद होगा from O levels as well, and then you have to revise it from A levels as well. ठीक है, अब याद रखिएगा एक नोट करके एक बात कि AgCl solid, remember this is one is white PPT, dissolve in dilute NH3 as it form a complex ion with a ion with ammonia. ठीक है, clear? So whenever they ask you why the precipitate get dissolved, क्यों dissolve हुए, so the reason it can make a complex ion with ammonia. So yes, in terms of test for the presence of halide ion, very simple. The reagent used are aqueous nitric acid, aqueous silver nitrate plus ammonia, which is called ammonical silver nitrate. The chloride ion white precipitate soluble in dilute ammonia. Bromide ion cream precipitate soluble in partially soluble in concentrated ammonia, and iodide ion yellow precipitate insoluble. ठीक है? So this is about the group 17, the general properties of halogen, O-level stuff. Going down the group, their physical state changes from gas to liquid to solid. Intensity of a color increases because the MR increases, number of electron increases, due to which their physical state or the boiling point increases. Halogen more reactive, become less reactive down the group due to increase in the atomic radius and decrease in the electronegativity value. Being fluorine is the most reactive and the strongest oxidizing agent. Iodine is the least reactive and the weakest oxidizing agent. Displacement reaction, more reactive halogen can displace a less reactive halogen, and उसकी ionic equation हमने देखी और हमने देखा कि आपके पास जो है वो क्लोरीन stronger oxidizing agent था, तो उसने Br negative को oxidize कर दिया. ठीक है? And then there would be no reaction if you are adding a less reactive halogen into aqueous solution of a more reactive halogen. And then reaction with hydrogen halide, hydrogen to make hydrogen halides. So yes, the reactions are basically depending on their reactivity conditions. इनकी reactivity पे depend करती है. तो yes, if you have fluorine, it react explosive reaction होगा in a cool dark condition. You have explosive reaction in the presence of UV light. In case of chlorine, you have a slow reaction on heating for bromine, as bromine is less reactive, or iodine may form an equilibrium mixture. Going down the group, the thermal stability of hydrogen halide decreases. ठीक है? क्यों decrease हो जाती है? Because the bond length increases and the bond energy decreases due to increase in the atomic radius of the halogen atoms. ठीक है? And then the test for the presence of halide ion, जो भी हमने सबसे लास्ट में कवर किया है. So make sure you know the color and the solubility of these precipitate. ठीक है? तो ये आपको कम से कम ये टेबल याद होना चाहिए. And the last thing जिसकी डिटेल हमें करने की जरूरत नहीं है कि why any silver halide precipitate dissolve, because they form a complex ion with ammonium. Next is basically the reducing power of halide ion and their reaction with concentrated sulfuric acid. This is one reaction that remaining. Halide ion का reaction concentrated sulfuric acid के साथ. And then the reaction of chlorine with sodium hydroxide, which is a disproportionation reaction. So we'll continue it in our next session, inshallah. Okay.